Hey, welcome to Smart Stuff. All right, so if you're gearing up for your professional exams, you know this topic is a big deal. I'm talking about early pregnancy. So that's what we're going to do today. Think of this as your high-yield visual guide, taking you all the way from conception to the fetal placental unit. Ready? Let's jump in. So let's start with a kind of mind-blowing question, right? How does a single fertilized cell, just one cell, manage to build not only an entire new person, but also its own complete life support system? We're talking about the placenta. It's one of the most amazing things in all of biology. And, for your exams, understanding how this happens isn't just cool, it's absolutely fundamental.
Okay, so here's the game plan. We'll kick things off with fertilization, the spark. Then we'll follow the journey to implantation. We'll see how the foundation gets built, looking at both the decidua and the chorion. Then we'll get into the lifeline, the circulation. And finally, we'll wrap up with all the different jobs the placenta has. Simple as that. Let's go.
All right, first stop, fertilization. This is where it all begins, right? The very moment a brand new, genetically unique individual is created. And it's not random. It happens in a very specific spot, following a very precise set of steps.
So this whole process goes down in the ampulla of the fallopian tube. And for sperm to succeed, it's got to complete this like a 4-step mission. First up is capacitation. Think of it as the sperm's final power-up. Next, the acrosome reaction. This is like the secret key that lets one sperm get through the egg's defenses. Then fusion. The sperm and egg merge their cytoplasm, their nuclei, everything, and bam! The second that happens, a block goes up so no other sperm can get in. It's seriously a high-stakes, super precise operation.
And this diagram just shows it perfectly. You can literally see the sperm making its way through that outer layer, the corona radiata, and then through the zona pellucida. And check out that moment right there, where the male and female pronuclei are about to fuse. That's the magic moment. They combine, they create a single diploid nucleus, and that's it. A new organism exists.
And that new organism? It has a name. The zygote. It's just one cell, but inside, wow, it's got all the genetic blueprints to build a whole person. But its job is far from over. Now it's got a big journey ahead. It has to travel, it has to divide, and it has to find a safe home to grow.
And this is super important. The zygote doesn't just hang out in the fallopian tube. No way. It immediately starts this pretty dangerous journey toward the uterus. And the whole time it's dividing and changing like crazy. It's really a race against the clock.
Okay, this timeline, this is pure gold for your study notes, so pay attention. Around day 4, we've got the morula, which arrives in the uterus. A day later, day 5, it's changed into a blastocyst, and it actually hatches out of that zona pellucida shell. By day 6, it starts to implant into the uterine wall. And by day 10, it's all tucked in. Implantation is complete. That is a ton of action packed into less than a week.
So let's zoom in on the blastocyst itself. It's basically got 2 parts you need to know. There's the inner cell mass. That's what's going to become the actual embryo. But then there are the outer cells, the trophoblasts. And honestly, these guys are the real MVPs of early pregnancy. They split into 2 important layers. You've got the inner cytotrophoblasts, kind of like the stem cells of the placenta. And then you have the outer syncytiotrophoblast. This is the powerhouse layer, the one that actually invades the uterine wall. And, this is a classic exam question, this layer starts pumping out beta-HCG. That's the hormone that basically sends an SOS to the body, telling it, hey, we're pregnant, don't shut things down. It keeps the corpus luteum alive and producing progesterone until the placenta's big enough to take over that job around week 10.
Okay, so the blastocyst has made it. But the uterus isn't just sitting there waiting. It's not a passive bystander. It's been actively getting ready to host this new arrival. And this specialized, prepared uterine lining, that's what we call the decidua.
And it's all thanks to that progesterone we were just talking about. The endometrium, the uterine lining, goes through this transformation called decidualization. The cells literally puff up, getting packed with nutrients like glycogen and lipids. It creates this perfect, cozy, nutrient-rich bed for the embryo. Without this prep work, the pregnancy just couldn't continue.
And this image does a great job of breaking down the 3 parts of the decidua. You've got the decidua basalis, that's the part right underneath the embryo. This is the maternal side of the placenta. Then you have the Capsularis, which kind of grows over the top of the embryo, and the Parietalis is just, well, it's the rest of the uterine lining. But the big takeaway, the one to remember for your exams, the Decidua basalis. That's the mother's main contribution to the placenta.
All right, so that's what the mother's side is doing. Now let's flip the script and look at what the fetus is building. The embryo creates its own structure, called the chorion, to make up its half of this whole interface.
And here they are, the chorionic villi. Just look at them. They're like these little fingers reaching out from the embryo, digging down into the Decidua basalis. And if you could zoom in on one villus, you'd see a core with fetal blood vessels, and it's covered by those two layers we already know, the inner Cytotrophoblasts and the outer Syncytiotrophoblasts. Now, the area with all these busy branching villi is called the chorion frondosum, and that is the fetal side of the placenta. The big space between all these fingers, that's the inner villus space. It's going to be super important in a minute.
Okay, the structure's built. We have the maternal side and the fetal side. Now we need to get the plumbing sorted out. We need a massive supply line. The best way to think about it is like a tiny village suddenly needing the water mains of a massive city. The mother's blood vessels have to go through this absolutely radical change.
And what's the goal of this massive construction project? It's to take these narrow, tight, high-resistance spiral arteries and completely transform them. They need to become wide open, low-resistance superhighways that can handle a huge volume of blood. Okay, this image right here, you have to understand this. On the left, that's a normal spiral artery. See how narrow it is? Now look at the right. This is what happens in a normal pregnancy. Those fetal trophoblast cells we talked about literally invade the artery, eat away the muscular wall, and turn it into this wide, gaping funnel. It's one of the most dramatic transformations in the entire human body. And the result of all that incredible work? Get this, a blood flow of up to 650 milliliters per minute. That's more than half a liter of blood rushing to the placenta every single minute. It's a staggering amount, and it's absolutely what's needed to keep up with the fetus's demands.
So what you end up with is two totally separate circulatory systems meeting in one place. You've got maternal blood pouring out of those remodeled arteries into that inner villus space, just bathing the outside of the villi. And then you've got the fetal blood, which stays safely inside the villi. It just kind of dips in and out of this maternal blood pool to do all its trading, picking up oxygen and nutrients and dropping off waste. But, and this is the critical part, the two blood supplies never, ever mix.
All right, we've built the placenta. We've got the blood flowing. So what exactly does this amazing temporary organ do? Well, turns out it's a total powerhouse that juggles a ton of jobs.
This slide right here is your high-yield summary, perfect for revision. The placenta is basically the fetus's lungs, its kidneys, its gut, and its hormone factory all rolled into one. It does the breathing, gets rid of waste, delivers all the food, and manages the hormones. I mean, it really does the whole shebang. And that's our journey. You know, when you really stop and think about it, the whole thing starts with just one single cell. And from that one cell, this incredibly complex temporary organ builds itself from scratch, perfectly supporting a new life, and then it's just gone. It's honestly one of the most mind-boggling processes in all of biology. Pretty amazing stuff to think about as